For this last slide, I'm going to do the very last problem from your guys' stamp. I don't know if it's the toughest, but it has a lot of steps to it, and these are kind of the thought processes and things you should be thinking about as you do this problem, okay? So the last one on your stamp is number 47, and it wants us to graph two full periods of y equals negative sine of 2 pi over 3. Whoa, got caught on my sweater there. X. Yep. Okay, so to make this happen, we can make a table, and I don't mind making a table, but a table and a graph say the same thing. So when you make a table and then you make a graph, you're saying the same thing twice. I'm going to go straight to a table, or straight to the graph on this one, and hopefully you guys can follow along. I'm going to make this one bigger than normal because it said I want two full periods. So I want it to repeat itself twice. The first step, always the first step on these, and when you ask me questions in class, I'm going to ask you, what's the first step? So let's start getting this down now. The first step is to find the period of sine and cosine. We want to know what the period is. The period is always 2 pi over b. In this case, b is 2 pi over 3. So we have some fancy fractional work here to do. It's going to be 2 pi over 2 pi over 3. Okay? What really is happening here, I have a 2 pi over 1 over 2 pi over 3. We're dividing fractions, so we multiply by the reciprocal. So really, I'm just going to flip this and bring it up to the top. So I have 3 over 2 pi. Easy enough. So now we have 2 pi's canceling, we have 1, and we're left with a period of 3. Okay, that's a little different, but we can handle that. Period of 3. So I'm going to go right here in the middle. That's going to be our period, 3. 2 periods within B, 6. All right, it wanted me to graph 2 periods. Now the half of that game. Half of 3, I'm going to call 3 halves. Yes, you can do decimals if you so desire. I just find it easier to work with fractions. Half of 3, 3 halves. Half of 3 halves, 3 fourths. Now we want 3 of those. So 1, 2, 3 fourths, 4, 5, 6 fourths, 7, 8, 9 fourths. 9, 10, 11, 12 fourths. 12 fourths is 3. And then we're going to keep going. We're going to keep that pattern alive. A lot of pattern seeking in this, for sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 fourths, 15, 16, 17, 18 fourths. Notice as I'm writing it, 18 fourths, I'm just kind of reducing in my head. 18 fourths, 18, 19, 20, 21 fourths. And then let's make sure we did it right. 21, 22, 23, 24 fourths. 24 over 4, 6. There we go. We got all of our key points. And notice here, when we start doing bigger ones, to get 2 full periods, I need 1, 2, 3, 4, 5, 6, 7, 8, 9 points for 2 full periods. We're going to have to do a bunch of that, so it's good practice. Now we just start cranking these things in there one at a time until we get a pattern. Once we find the pattern, it's not too bad. Really, we've done all the legwork on this. So let's plug in 0 first. If I plug in 0, okay, 2 pi over 3 times 0 is 0. Sine of 0. Sine of 0 is 0. With a negative sign, it doesn't matter. So our first point's the origin, 0, 0. Next one, 3 pi over 4. Okay, so I'm going to plug in 2 pi over 3 times 3 over 4. And at first glance, it looks like it's going to be a mess, and I have to find this crazy sign. I better get out my calculator. No, no, no. We don't have to do that. The 3's are going to cancel. 2 over 4 just reduces to 1/2, and I'm left with pi over 2. Right? If we break these periods up into fourths, we're always going to end up having to take the sine or cosine of our cardinal directions, the one we like. So the sine of pi over 2, that's 90 degrees, that's 1. With a negative sign in front of it, that would be negative 1. So 3 fourths, I'll put negative 1 here and 1 here. Negative 1. Next, 3 halves. Or do we need that? Okay, at this point, and obviously I've done a bunch of these, but you guys can start to get the hang of this. On sine, it always starts at a node, goes to an antinode. In this case, it went down because this is negative. It flipped upside down. But what's the next one going to be? Yeah, it's going to go back to a node. Then what's the next one going to be? So node, minimum, node, maximum. Node, minimum, node, maximum, node. And we have 2 full periods. That's it, all right? Yes, you could plug them all in and you would get this and see this, but we can start to generalize these things. That should have been a little straighter. Look, I'll just make the dot really big. So now we try to graph this thing as best as possible. Notice this is the middle of a sine curve. That's when it's steepest. That's going to be a straight line. Some people I've seen try to make this like a curve right here. It's not. It curves at the ends of these things, at the antinodes, not the nodes. So let's see if I can do this thing justice. Something like that. Just a sketch. I'm not getting pretty with it. We have Desmos and other graphing software to help us graph these, but a little sketch by hand for y equals negative sine 2 pi 3 over x. 2 full periods. Okay. Your guys' stamp then, I'll put it right here, is going to be page 410, 1 through 11 odd, 31, 33, 35, 43, 45, 47. Have that due next time I see you. Again, this is for effort, so you need to try all these, bring your questions, and I'll see you on the flip. Moving on.